All right, this is number 9A, and we are at the top of a cliff, and somebody's going to fire something off a cliff at an angle of 37 degrees. So let's do that, 37 degrees, with an initial velocity of 125 meters per second. We know that the cliff is 205 meters tall, so let's list that. And we are supposed to find the total time that the object is in the air. So I'm going to start by dividing the problem in half vertically. And I'm going to start by finding my components, my x and y components. Right now I really don't need or care about the x component, but it's going to turn out to be 125 times cosine of 37. I'll just store that there. But I do need the y component. And the y component is going to be 125 sine of 37. And that turns out to be 75.23 meters per second. So I can use this information to find out how long it's going to take to get to the top of the path from the top of the cliff. So the final velocity up here at the top would be 0. I'm looking for the time, and we know that the acceleration is going to be negative 9.8. So we can find the time it takes to go up by using our first acceleration equation, and we would be looking at it in the y direction. So that's going to be 75.23 minus 9.8 because it's going up, and I'm solving for t. So when we do that, we find out that it takes 7.68 seconds to go up. So we're just going to store that number there. But we also need to know how high up it's going to go. So I'm just going to put a D in my list here. And really what I'm looking for now is like this distance here, how high up it goes. So I'm going to use my third acceleration equation. Whoops, I'm off the page here. All right, the third acceleration equation. And that's 0. This is still 75.23 squared plus 2 and a minus 9.8 in D. And so we find out that it goes up an additional height of 288.75 meters. So that's important to me because we know that the original height of the cliff was 205. We now found out that it went 288.75 more. So now I'm going to draw my attention over here to the right hand side, and the total height then from top to bottom, the total height is going to be the 205 plus the 288, and that turns out to be 493.75. So there's a lot of things that I could find out about this problem right now, but really all I need to know is how long it takes to fall down. So we're just going to look only at the right hand side of the problem, and we are going to assume that we are just going to drop it from the top, because the time it would take to parabola down would be the same as it would take to drop from the top. So in just the y direction on this side, we could assume that the initial velocity is 0. And so to find the time, I'm going to use the second acceleration equation, VIT plus 1/2 AT squared. But this is going to be 0 because we're pretending we're dropping it. So the total height is 493.75, and so we have 1/2 9.8 times t squared, and we find that the time it takes to fall down is 10.038 seconds. So I'm going to circle that. So the total time then is going to be the sum of the time it took to go up plus the time that it took to go down, and so the total time will equal 17.72 seconds.